Dear attendees, a report on the topic is brought to your attention: prediction of the duration of inpatient treatment of diabetes in children based on neural networks. Today, in all spheres of life and activity, people use the knowledge obtained from data. This also applies to medicine and its areas, which is a priority area in various countries of the world. The number of certain types of disease is increasing. One of them is diabetes. The use of neural networks to predict the duration of inpatient treatment for diabetes can help medical professionals determine the most effective treatment methods, provide effective planning of treatment projects, and analyze their effectiveness. The purpose of the work is to substantial the knowledge base that provides a prediction of the duration of a patient treatment of diabetes in children based on the use of the developed neural networks model of direct communication. To achieve the goal, the following tasks should be solved: propose an approach and prepare data for predicting the duration of inpatient treatment of diabetes in children, to justify the parameters of the neural network model of direct communication for predicting the duration of inpatient treatment of diabetes, and to evaluate its accuracy indicator. We present the main stages of developing a model for predicting the duration of inpatient treatment of diabetes in children based on the use of neural networks of direct communication. The stage of forming a database on the treatment of diabetes in children is key to the successful development of a model for predicting the duration of inpatient treatment. One method of data collection is the use of electronic medical records data. With the help of electronic medical records, 779 instances of data on inpatient treatment of diabetes in children. We cleaned the data and filled in the missing values. Based on the result of this stage, data were prepared. A fragment of each is presented in the. At the next stage, the input parameters of the model for predicting the duration of inpatient treatment of diabetes in children are determined based on the use of neural networks of direct communication. This step consists in selecting the attributes most correlated with the target attribute bad days using a correlation matrix. For each input factor, according to table, we find their average number, formula 2. After that, we calculate the correlation matrix, the elements of which are determined by the formula 3. The covariance between the input factors and the target attribute is determined by the formula 4. A correlation matrix displays the relationship between attributes in a data set. For the target attribute bad days, the correlation with each other attribute was calculated using formula 3. The obtained results are presented in table. Based on the data in table 2, it should be noted that most of the attributes have a weak correlation with the bad days attribute. This suggests that they should not be used as input parameters of a neural networks model. As a result of data cleaning, we built a correlation matrix in the form of a thermal diagram, which reflects the input parameters of the model. In our research, it's accepted that the architecture of the model is chosen according to the feature of the requirement for the task of prediction, the duration of a patient treatment of diabetes. In this case, a model with a simple neural networks with a variable number of hidden layers having 64 neurons is adopted. It's known that This architecture of the neural networks model can be effective if there is not a lot of data and they have a sufficiently simple structure. In addition, our research compared models from 2 to 7 layers. It's impractical to increase their number to avoid retraining the model. The following conclusion can be drawn from table 3. The slowest to learn was model 4, which learned at 3 milliseconds per step, while all other models learned at 2 milliseconds per step. Model 6 and 7 has losses of 0.0469 and 0.0465 respectively. Have the best loss indicator on the test data. The worst performance was shown by model 3 with the learning speed of 2 milliseconds per step and loss on test data of 0.0498. In general, we can say that the learning speed of the model doesn't always correlate with its accuracy, so it's necessary to pay attention to the final indicator on the test data, which are presented in the figure 6. It was established that all variants of the studied models have very low losses, which indicates their effectiveness. It's also important to pay attention to the difference between the losses on the training and test data. Based on the obtained dependencies, it was established that the best results are shown by model 2, which is sufficient for learning 50 epochs. All other models are subject to overtraining. Model 2 has the parameters presented in table. Based on the research result, it was established that the model with the smallest value shown the best results. Therefore, the proposed rational neural networks model of forward communication for predicting the duration of inpatient treatment of diabetes in children has an architecture consisting of 2 layers. The first is the dense type with 64 neurons and the RALO activation function, and the second is the dense type and 1 neuron. The total number of model parameters is 385. In the proposed model, the learning rate is 0.0001. This value is set experimentally and is small, which can help avoid divergence or skewing of the model. The proposed approach to predicting the duration of inpatient treatment of diabetes in children is based on the use of forward propagation neural networks and involves 9 stages. The peculiarity of this approach is that the formation of database and knowledge is carried out based on taking into account the peculiarities of inpatient treatment projects, thanks to the computer analysis of historical data and the excursion of simulation. This ensures a systematic consideration of the interrelationship between the factors and the duration of inpatient treatment of diabetes in children. The described approach is the basis of qualitative data preparation and increase the accuracy of neural network models for predicting the duration of inpatient treatment of diabetes in children. Based on the use of the developed approach as well as using the prepared data, the parameters of the neural network model of direct communication for predicting the duration of patient treatment of diabetes were substantiated and its accuracy indicators were evaluated. The proposed rational feed-forward neural networks model for predicting the duration of inpatient treatment of diabetes in children has an architecture that involves 2 layers. The first is the dense type with 64 neurons and the RALO activation function, and the second is the dense type and 1 neuron. The total number of model parameters is 385. In the proposed model, the learning rate is 0.0001. Further research should be conducted on the development of decision support system that will provide a solution to the problem of planning diabetes treatment project in children using a valid feed-forward neural network model to predict the duration of their inpatient treatment. The report is over. Thank you for your attention.